Hey guys, so I'm going to go through the lesson in case you missed it or if you want to review. So the first thing I had you guys do is to look at a problem where you have multiple steps where you're converting units and draw the path. This is a technique that can be helpful if you're kind of stuck and don't know where to start. So in this example, we're wanting to find out how many hamburgers you would have to wrap to make $1 million. So that means our final unit should be in hamburgers. And sorry, it's hard for me to write on this sometimes. So, and then we're starting in dollars because we're starting with $1 million. So one strategy is to figure out, well, if we're starting in dollars, what can we convert dollars into? And if we look up and read, it says he gets paid $960 every 2 weeks. So that means we can turn our dollars into weeks. And then from that, our weeks, we can turn into how many days he works a week. And then from that, we can turn it into hours. And we know how many hamburgers he can make in an hour. So this kind of gives us a guideline for how we're going to solve our problem and how we're going to set it up. So we're going to start with our $1 million. And since we have dollars and we want that to cancel, we're going to put our dollar sign on the bottom. We know that there's $960 in 2 weeks. So it's important to put the 2 up here for 2 weeks. So now we have it. So our dollar signs cancel, but not the numbers. And we're left with weeks. We know that in 1 week, he works 5 days. So now our weeks cancel, we're left with days, and we know that in 1 day, he works 8 hours. Our days cancel, we're left with hours, and we know in 1 hour, he makes 350 hamburgers. So our hours cancel, and we're left with hamburgers. So now we just put this into our calculator, and remember that everything on the top we're going to multiply and everything on the bottom we're going to divide. So I can actually show you how we're going to put that in with my calculator here. So we have 1 million times our 2 weeks at the top times our 5 days at the top times our 8 hours at the top times 350 hamburgers equals this, but we have to divide by our 960. So we're left with this number. Let me scroll down a little bit. 336,000 hamburgers. But we have to remember our sig figs. So for this, we go to our number we started with. It only has one significant figure, so our answer will also have one. So it will round to 300,000 hamburgers. Or you can write that as 3 times 10 to the 1, 2, 3, 4, 5 hamburgers. So this is just a nice way that if you're having problems, knowing where to start, you can kind of write out the path. So it's a strategy you can use. Okay, but where we left off last time was looking at molar mass. So for molar mass, we are just looking at the mass of the whole compound or element that we're looking at. So just a quick reminder, if we're looking at oxygen, we will go to our periodic table, find oxygen. So my numbers might be slightly different than the ones on your periodic table, but it should be fairly similar. So oxygen, we see the mass is right here is 15.999. So we're going to go here. That means our molar mass for oxygen is 15.999. And the important thing to remember for this is this mass has a unit and it is in grams per mole. We can abbreviate mole, M-O-L. Then the next example is xenon. So xenon's over here. Its mass is 131.29. again, grams per mole. These are pretty straightforward. The next one is a little more tricky. We have multiple elements in one compound, so we're just going to add them all up. So carbon, first we look, is 12.011. Oops. So 12.011 plus our hydrogen, and if we see that there are actually 4 hydrogens, so we're going to multiply 4, and our mass for hydrogen is 1.008. So there's a couple ways you can do this. You can put it in your calculator using the parentheses, or you could do this first step, 1.008. Just remember that if you're rounding, once you round at the very end for your decimals for sig figs. So that means we want to use all of 4.032, and we're adding that to 12.011. So our total mass is 16.043. And here we have to use sig figs again. We're basically adding for all of this, so we're going to use our decimal place rule. So each of these numbers go 3 after the decimal place, so will our answer, which it already is. And the unit is grams per mole. So that's our answer. So we're just adding everything up. So here's some examples. You can pause the video and try them on your own. Okay, so our first one is sodium 22.990 plus our bromine, which is 79.904. We put that in our calculator just to make sure we're doing it right. 22.990 plus 79.904. We get 102.894. Again, 3 after the decimal place for both of ours, which is what our answer is, grams per mole. Now this next one has 3 elements, so we do it the exact same way. We just add up all 3. So lead is here, 207.2, plus our sulfur, which is here, 32.06, plus, and remember we have 4 of our oxygen, so we have to do 4 times oxygen, which is 15.999. So we can do 15.999 times our 4. We have to use that whole number when we're adding it. 32.06 plus 207.2, and we have 303.256. But remember our decimal places, this number has 3 after the decimal, this has 2, this has 1. So that means our final answer will only go 1 place after the decimal. So it would be 303.3 grams per mole, because this 5 causes us to round up. Okay, so next you can try these next 2. So if you can pause the video and try them on your own. Okay, so this first one, we'll look up calcium, 40.078 plus, and so now remember when we have parentheses, that means this subscript applies to both things. So we have 2 times our oxygen, which is 15.999, plus we have 2 hydrogen as well, so 1.008. And we can put this in our calculator. I'm going to do 1.008 and go ahead and add our 15.999, and then do that whole thing times 2, plus our calcium, which is 40.078. Oops. Let me try that again. Okay, so we have 74.092, and everything has 3 places after the decimal, so we're good. Grams per mole. And so then the last one we're going to try is O2, so that's just oxygen, and we have 2 of them, so 15.999 times 2. 31.998 grams per mole. Okay, we'll try one more, so you can pause the video and try this one out. Okay, this one we're going to start with iron, 55.845. So this one's a little trickier. So we have actually 4 total hydrogens because we have 2 of this whole thing. So we have 4 times our hydrogen, which is 1.008. Plus we have 2 phosphorus, 30.974. And then we actually have 6 oxygen. Okay, and this time I'm going to show you with our parentheses, because I do actually have parentheses. So 55.845 plus, there we go, parentheses 4 times 1.008, close parentheses, plus 2 times our 30.974 plus 6 times our 15.999. And so then when we do all that, we get 217.819. And everything has 3 places after the decimal, so we're good, and this is grams per mole. That's probably one of the trickiest ones that you'll have. Okay, so the reason that we are looking at the molar mass is because we can actually use it when we are converting things. So we can use it as our conversion factor. So our example here, we have 1.2 grams of aluminum. So if we're going to convert this into moles, just like before, we want our grams to cancel, so we're going to put grams on the bottom, and we're going to convert into mole. And the way we know what mass and what numbers to put in here is to look at the molar mass. So we look at aluminum's molar mass. If we go over here, aluminum has a molar mass of 26.982. And you remember that's grams per mole. So that means we're going to put this number with the grams. So we're going to put it down here, 26.982. And then we have our grams per mole over here. So our grams are going to cancel, and we're left with moles, which is what we want. So we're going to do 1.2 divided by 26.982. And we're left with this huge long number. So we have to look at our sig figs. We were dividing, so we're looking at the number of sig figs, not the number of decimal places. And 1.2 only has 2 sig figs, so our answer will also only have 2. So we will write it as 0.044. And our unit is moles of aluminum. Okay, so you can try this next one. You can pause the video. Okay, so this one we will do 5.8 grams of carbon. Our grams go on the bottom again. We'll look at the molar mass of carbon, which is 12.001, and that goes down here, 12.001 grams per mole. Our grams cancel, so we're doing 5.8 divided by 12.001. We get this number. We have 2 sig figs, so we write that as 0.48 moles. Okay, so now we're going to do it the opposite way. Now I'm giving you moles and you need to tell me how many grams. So we do this very similarly. We put 1.2 moles. So this time we put moles on the bottom because that's what we want to cancel, and grams on the top. We look up the molar mass of chromium, which is here, 51.996. And it goes with the grams because remember that's grams per mole. So this time we're do 51.996 times 1.2. And we have 2 sig figs, so we will write 62 grams. So every time that you're given moles, you're going to be multiplying, and every time you're given grams, you're going to be dividing, but it's really easy to get that confused and mixed up. So you can always just set it up and see how the units are going to cancel. So you can try this next one on your own. And we'll do 3.4 moles of titanium, cancel with our moles down here. Titanium is 47.867 per 1 mole. Moles cancel. And our answer is 162.7478, but we only have 2 sig figs. So the way we write that is 1, 6, and 16 isn't quite the same as 162, so we have to put this 0 as a placeholder for our answer. Okay, so here's a couple more examples. This time you have to actually calculate out the molar mass. So I'll show you how to do a couple of those. So we have 53.1 grams of CH4. We're going to set it up the same way with grams down here and moles on top. But for CH4, we need to calculate the molar mass. So carbon is 12.001 plus our 4 hydrogen, 1.008. So we can put that in here. We can do 12.001 plus 4 times 1.008 equals 16.033, and that goes with our grams. We put a 1 up here. Our grams cancel and we're left with moles. So that means we need to do 53.1 divided by 16.033. So notice that I did not round the 16.033. We're not going to round until we're at the very, very end. So this is our answer, but we only have 3 sig figs because this number right here only has 3. So we'll write 3.31 grams of CH4. So you can try this next one. Let's see. Actually, you can try these next 2. Okay, so this first one, we do 2.3 moles of H2SO4. I'm going to go ahead and do the mass of H2SO4 over here, just in the calculator. Okay, so we have 2 hydrogens plus sulfur and then we have 4 oxygen. So that is our molar mass of H2SO4, 98.072. And that's grams. And we put moles down here because they needed to cancel. So then we're going to take that molar mass times 2.3. And we're left with this. We only need 2 sig figs. So this 225 actually rounds to 230 grams. This next one, we have 57 grams of magnesium oxide. Our grams go down here. Our moles go up here. So I'll do that on here. Magnesium is 24.305. Plus we have 2 hydrogen. Plus we have 2 oxygen. So this is our molar mass for that. And that goes with our grams again, 58.319. So the grams cancel. So this time we're going to do 57 divided by 58.319. We have this number. We use 2 sig figs, so this is going to be 0.98 moles. Okay, so this is your ticket out the door. If you missed it before, these first two, you're calculating the molar mass of those different things, and then the last two, I'm giving you grams, and I want to know how many moles, or I'm giving you moles and wanting to know how many grams. Don't forget that your final answer needs to have the units labeled and the correct number of sig figs.